Welcome to the fastest way to learn data structures and algorithms. Today, we're mastering a fundamental interview classic, LeetCode 20, valid parentheses. If you want to understand how compilers and text editors check your code for errors, this is the problem to master. Let's dive in. The challenge is straightforward. We're given a string containing just 6 characters, opening and closing parentheses, brackets, and curly braces. A string is valid if 3 rules are met. 1. Open brackets must be closed by the same type. 2. They must be closed in the correct order. And 3. Every closing bracket must have a matching opening bracket already waiting. How do we track waiting brackets? We use a stack. A stack follows the last in, first out principle, just like a stack of plates. When we see an opening bracket, we push it onto the stack. When we see a closing bracket, we look at the top of the stack. If the top matches our closing bracket, we pop it off and continue. If it doesn't match, or if the stack is empty when we need a match, the string is invalid. Finally, if the stack is empty after processing everything, we have a perfect match. Look at the screen. Our input string is bracket, square bracket, close square, brace, close bracket. We start at the first character, an opening parenthesis. The stack is empty, so we push it on. Next, an opening square bracket. We push it onto the top of the stack. Now, we hit a closing square bracket. We check the top of the stack. It's an opening square bracket. That's a match, so we pop it off. Next, an opening curly brace. Push it onto the stack. Then, a closing curly brace. It matches the top, so we pop it. Finally, a closing parenthesis. It matches the original opening parenthesis at the bottom of our stack. We pop it. We've reached the end of the string, and our stack is empty. That means every bracket found its partner in the right order. Result, true. In our Python solution, we use a dictionary to map closing brackets to their opening partners. This makes our checks super clean. We initialize an empty list to act as our stack. We loop through every character in the string. If the character is a closing bracket, we check if the stack is empty. If it is, or if the top of the stack doesn't match our dictionary, we return false immediately. If it's an opening bracket, we simply append it to the stack. At the very end, we return not stack. This returns true only if the stack is completely empty, confirming every bracket was closed. For time complexity, we traverse the string exactly once, performing constant time push and pop operations. That's O of n, where n is the length of the string. For space complexity, in the worst case, like a string of all opening brackets, we store every character on the stack. That's also O of n. And that is how you solve valid parentheses using the power of stacks. If this helped you visualize